And now back to lesson 10.5 for Algebra 2. Law of signs continued. Now we are looking at the ambiguous case of law of signs, and this is when you are presented with side-side angle, two sides, and the non-included angle of a triangle. There's several things that can happen there because this does not follow the laws of congruence. We're not guaranteed to have the same shape of triangle when we're given two sides and an angle for two triangles, but what can happen here? So first of all, if A is a right or obtuse triangle, we could end up with exactly one triangle, like it shows down here on the bottom, or if the side A is too short, it might not reach and we might not have a triangle at all. And that can also happen in a right or an obtuse triangle, and this is also a right or an obtuse triangle depending on this angle right here. If it's right or obtuse, that's all that can happen. It either is one triangle or it's not long enough and it doesn't make one. If A is shorter than B, then you're not going to end up with a triangle. Over here, what we have is if A is an acute angle. So when they give you side-side angle, if this angle that they give you is acute, we have four different things that can happen. Let's start top left. If A is shorter than the height, we'll explain how to find the height in a minute, then we are not going to have a triangle because it doesn't reach. And if A is equal to H, then we're going to have one triangle, and it's going to have a right angle right there, actually, because that's right where it just touches. So if A is equal to H, we get one triangle. If A is just a little bit longer than H, but still shorter than B, so that's when we get the two triangles. So that when that A length, it could have this triangle out here with an acute angle, or it could have this triangle on the left here with an obtuse angle. So these two triangles, this is the tricky one here where we have to figure this out. If A is longer than B, then I'm only going to end up with one triangle with this angle being A, because if it was over here, that wouldn't have angle A in it anymore. So we're going to look at different problems. We're going to come back to this page to see what kind of situation we have. But the first thing you need to know is, how do I find H? So what they're going to do in these problems is they're going to give you an angle and two sides, side B and side A. If they name them different letters, we'll deal with that. But how do you find the height? Well, height is, this is always a right triangle, because see how the H is always that drop down perpendicular height of the triangle. So H is, sine of A is H over B. I'll write that down. Sine of A is H over B. So I would multiply by B. So H is B sine A. Kind of like in that area formula we were doing a little bit ago. Just like it, actually. This is how you find height. So if this is not on your notes, you should write this down. You should highlight this. This is how you find H so that you can answer this question. Let's go do some examples. Let me just skip that page. If one is, we can only have at most one obtuse angle in a triangle. Let's do this example here. So determine the number of triangular banners that can be formed using the measures. A is 50, B is 20, and the measure of angle A is 28. Then solve the triangles, round to the nearest tenth. So first of all, we got to figure out how many triangles we have. They gave me angle A, side B, and side A. So angle A is an acute triangle, an acute angle. So I'm going to look at my chart under acute angles. I know A is 50 and B is 20. Let's go ahead and find out what H is right now before we even go look at the chart. So B is 20 times the sine of 28. 20 times the sine of 28 is 9.4. Make sure you're in degree mode. H is 9.4. Okay, let's go look at that chart that we have to see what we've got. H was 9.4, A was 50, and B was 20. So let's start with this one. Is A less than H? Nope. Is A equal to H? Nope. Is H the smallest? Yes. And then A and then B? Nope. A is bigger than B. We're in this fourth category right here. So we only have one triangle. That's the good news. We only have to solve for one of them. So what I would do right up here is A A is greater than B. My pen is not writing, so let's try that again. A is greater than B, so there's only one triangle. Okay, there are two questions up here. Determine the number of triangular banners that can be formed. Only one triangular banner. Okay, there's usually two parts to these questions, so make sure you answer that. Don't just start solving. You need to answer 1, 2, or none. Now, it says solve. Solve the triangle. Well, I have angle A, side B. So what I need to find still is angle B, angle C, and side C. So when I have these three things, I will be done. We can use the law of sines now. So let's go sine of angle A, 28, over angle A goes with little a, so 50, equals, I know little b is 20, so I'm going to put the 20 down here on the bottom, and sine of angle B on the top. Now, in order to solve this problem, I only have one thing I don't know, the angle B. I'm going to cross multiply, so I get 20 sine 28 equals 50 times sine of B. When I go to solve this, I'm going to type in my calculator, 20 times sine of 28 divided by 50. Okay, here's the trick. You're going to get some decimal in your calculator when you type this in. Okay, so make sure you type that in your calculator. And then, how do I solve for angle B? That is not the answer. We're not done because this is sine of B. So what I need to do is undo that, which is the inverse sine. So we're going to do sine inverse of that stuff I had there. So instead of trying to round my decimal, because every little decimal makes a big difference with sine, cosine, and tangent, I'm going to use that exact value by pressing second. The negative button has ANS above it, and it's going to put ANS in here. So if you do, it's really not that hard once you get used to it. You get this answer here, you hit second sign, second answer, and then out will plop your answer for angle B, which is rounded to the nearest tenth, 10.8 degrees. Round to the nearest tenth, yes. Okay, so I found angle B, 10.8 degrees. I'm going to write it over there. Okay, so just so you know, your answer here will always be a decimal, probably less than 1. Otherwise, something's wrong, which means it's not an angle, or maybe there's not a triangle there. So if there's no triangle, you might actually get an error. That can happen. Now I know angle B, and I know angle A, so I can probably find angle C. We already decided that there's one triangle, and by the way, it's going to be obtuse because of the drawing on the little chart page. So let's do 180 minus 28 minus 10.8 to find out what angle C is. 141.2 degrees. So angle C is 180 minus angle A minus angle B. And we get 141.2. Now that we know angle C, we can find side C. One thing left to find. We're going to go back to our original setup here. So this is, I'm going to go back and I'm going to add angle C in here. Sine of 141.2 over little c. And then I'm going to ignore the middle and solve this proportion. So cover up that middle part. You still just have a two-way proportion here. And so we're going to cross multiply. 50 times sine of 141.2 equals C times sine of 28. So I'm just going to divide by sine of 28, and I will have side C. So whatever you get when you type this in will be your answer for side C. And I got 66.7. If there are units, I would put units there, but A and B don't have units, so C doesn't either. I have a double equal sign there. There we go. Okay, answer is 66.7. All right, let's do another one of these. Here we go. Determine the number of triangular quilt pieces that can be formed using the measurements A is 14, B is 20, and angle A is 39. So A is 14, B is 20. We know A is less than B. We can go look at the chart, but I would like to find H first. H equals B, which is 20, times the sine of A. 20 times sine of 39 is 12.6. So let's put that in our chart here too. 12.6, 14, 20, that's in order. So H is less than A is less than B. And if you have your little chart handy, you can look at it, but that means we have two triangles. So here we go with one of the problems where we're going to have to solve both the outside acute angle for angle C, and also here where angle C has an obtuse angle. All right, so we know we're going to have two triangles, so we can make two triangular quilt pieces. That's my first answer. Solve each triangle. I'm going to have two different triangles. So I'm going to start over here. And we'll just start with the law of sines like we always do. Sine of angle A is sine of 39 over side A equals sine of angle B over 20. So I can use this to find angle B. And that is a C. Oh, goodness. I'm going to fix that up. Maybe. Okay, here we go. So cross multiply, divide. You're going to get sine of B equals sine of 39 times 20 divided by 14. Make sure you close your parentheses and then hit second sign, second answer, second negative, and you will get, for angle B, 64 degrees. It says the nearest tenth, but I just got 64. So if you have a tenth on there, that's fine too. I'm not sure. All right, let's just finish solving this one, and then I'll explain how to get that other triangle, because if we just follow law of sines, we're just going to get one answer. Now, to find angle C, same thing. They have to add up to 180, so I'm going to do 180 minus 64 minus 39 is 77. So that means angle C is 77 degrees. Almost done. I now have sine of 77 over little c to add to my little formula. I'm going to use the A part because that's the part I already knew, and the C part, and cross multiply here. So C is 14 times sine of 77 divided by sine of 39. Cross multiply, divide by the other piece to get your answer. Whatever that is when you type it in, 21.7 is your answer. These have units of centimeters on them, so I'm going to keep units of centimeters on my length down there. All right, now what in the world, why is there a second triangle? Well, the good news is, if nothing else, you should be able to solve this one because it's exactly the same as every other problem. The thing where people run into trouble is they forget to check for that second triangle. It only happens in the side-side angle case where H is less than A is less than B. All right, I'm going to show you back on the chart that we had an angle of 64 degrees for our angle C. If angle C is 64 degrees right here, then I want to know what this angle would be for angle C. If this was a 64, keep that in mind. For some reason, my pen is not working anywhere. This is 64. This A is the same length on both sides. So right here in the middle, this red triangle is isosceles. So if this is 64, then this inside is 64. So what is this obtuse angle right here? 180 minus 64. It's 116. So either C is 64, or it's the supplement of that 64, which is 116. So when I do my very first step, and I solve for B, oh, it was angle B. I was pointing to the wrong angle, or I named it the wrong thing, but it was angle B. I got 64. Basically, I'm going to take that step right there, and instead of it being 64, it could be the supplement of that, which is 116 degrees instead. So I just take that first answer I got, whatever the first one is, and take the supplement, or 180 minus it. Okay, now I'm going to completely ignore all these answers that I got before and just keep the original information and my new angle B, and I'm going to set up the problem again. So now I have sine of 39 over 14. I know angle B is 116, sine of 116 over 20. Those all have numbers, so there's no reason to put that there. How do I find angle C? Well, now I have two angles, so I can find the third one. 180 minus 116 minus 39. Often this one will be small. I think on your homework there's some that are very small, like less than 10. Angles that are less than 10 are very small. And now all I have left to find is little c. So I'm going to, if angle C is 25, I'm going to put the 25 up here. And all I have left is this solve right here. So 14 times sine 25 divided by sine 39 is C. Answer here is 9.4 centimeters. If you want to take the time to type that in your calculator and check, that would be great. All right, so that's the main idea. When there are two triangles, you solve one just like you did, and then take that first angle you got, supplement it, and then solve the rest of C. I've got 3 more examples here. They are just more of this same kind. So if you feel like you have it, you are welcome to go and try to do the homework. If you get stuck, come back and watch a couple more examples. This one here is given to us in a picture form. So if it's in a picture, it can't be 2 different triangles. So we only have to find one of them. So that's the good news about this one. We know there's only going to be one triangle. And we're going to round to the nearest 10th. All right, so looking at this triangle, we have angle Q and angle R. Let's start with finding angle P, because angle P shouldn't be too bad. We know the 3 angles in a triangle need to add up to 180, so we're just going to do 180 minus 39 minus 36, and we end up with 105. I like to label that on my graph. Now, I had to do that first because in order to use the law of sines, you have to have an angle and its opposite. An angle and its opposite, an angle and its opposite. The only one that I actually know both numbers on now is angle P. So I'm going to start with that one. Sine of 105 over 10 equals sine of 39 over R, it doesn't matter which one you do first, equals sine of 36 over Q. Now, if I had a hand, I would cover up part of this, like I would cover this up and just focus on this first part, of the proportion and cross multiply and solve there. So let's do that first and solve for little r. So to solve for little r, we do 10 times sine 39, close parenthesis, divided by sine of 105. That will give me little r. Little r is 6.5 rounded to the nearest 10th. In order to find little q, I then would ignore the middle here and look outside here. To find q, I'm going to do 10 times sine of 36, close parentheses, divided by sine of 105. Now, I'm saying close parentheses because when you type it in some calculators, it starts one, so you have to make sure you close it before you divide. All right, so that is little q. So when you type that in your calculator and get q, you get 6.1. R and Q are very close. It's a good idea to go back and look at your picture. Is 6.5 reasonable? Is 6.1 reasonable? Well, the biggest angle should have the biggest side, and the smallest angle should have the smallest side. So these all look like good, reasonable answers. All right, here's another one of those ones where we have to decide how many triangles and then solve. So this time, angle A is 105. That's the good news. We get to start right away with A is 105, which means we're starting out with an obtuse triangle. And so when we go look at our chart, if we start out with an obtuse triangle, we are over here for sure. And then we just have to decide if A is less than B, there is not a triangle. And if A is bigger than B, then there is a triangle that we need to solve. There will be a couple problems on your homework that are no triangle. Guess what? You don't have to do any work on those. All right, so if A is greater than B, which it is, A is greater than B, then we do have a triangle. So there is one triangle. Then solve it. Or then, there's only one. All right, to solve it, I'm going to find angle B, I'm going to find angle C, and I'm going to find side C, because I have the other 3 pieces. All right, here we go. Sine of the angle I know over its side equals sine of the angle I don't know over its side. So we can start out with finding angle B. This one, I would do 6 times sine of 105, close parentheses, divided by 10 equals sine of B. So then you're going to have to push the second sign of second answer and get your angle. So what that one comes out to is 35.4 degrees. All right, I found angle B. Now in order to find angle C, you just subtract from 180. So 180 minus 35.4 minus 105 is 39.6 degrees. Now that I know that, I like to just add it to my already written proportion so I don't have to rewrite. Sine of 39.6 over C. Ignore the middle one and go out here, cross multiply and divide. So sine of 39.6 times 10 divided by sine of 105. Side C is 6.6. You can draw them if you want to, but you don't have to. All right, that one only had one triangle, so we are done. Let's do one more example. So here we have angle A is 25, B is 26, and angle A is 69. So A is 25, B is 26, and A is 69. H is B times sine of A, which is 26 times sine of 69. We multiply that out. H is 24.3, which means it goes in this order. H is less than A is less than B, which means we have two triangles. Okay, so I wanted to do another example with two triangles. Here we go. First triangle, find angle B. To find angle B, I'm going to use sine of 69 over 25, sine of B over 26. Cross multiply, divide, inverse sine. That will give you angle B is 76 degrees. Angle C and side C, we can still find. Subtract from 180 and then set that up. While I'm at this step, I'm just going to come over here and start solving the other triangle as well. And I can do that because I know if this is 76, then this is its supplement, so it's 104. Okay, so all you have to do is find that first angle B and then find a supplement and you're ready to go over here. Okay, now let's do the next step. To find angle C on both triangles, I would take 180. Let's do the first one. 180 minus 69 minus 76 is 35. And I'm going to do this one now. 180 minus 104 minus 69 is 7. So this angle C is tiny. We have 104 and 69 degrees. There's not much left over. Very, very slim angle. So that means my side C is going to be really small also. All right, to find side C, we'll just set up that A proportion. Sine of 69 over 25 equals sine of 35 over C. Just cross multiply and divide to find this one. You get 15.4 centimeters. And over here, we would do the same one, so you don't have to write it out, but this time my angle up here for C is 7. So when I cross multiply and divide this one, this is going to be a really small number. It comes out to 3.3. So this triangle has a side of 26, a side of 25, and a 3.3. So there's my obtuse angle. Anyway, that's what it looks like. So there's a few examples of the law of sines for you. Be careful for those ones that have two triangles. You need to show your work and get both of them. If the situation at the beginning says no triangle, you just need to show me what you got for your H. I should still be able to find H. And then you can write no triangle and you're done. That concludes lesson 10.5.